Hello everybody, today we'll be doing the container with most water. You are given an integer array of heights of length n. There are n vertical lines drawn such that the two endpoints of I line are I and 0 and I and height of I. So for two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water of a container can store. Note that you cannot slant the container. So here we're given an example of this particular input, and we have an output of 49. The reason for that is because we take the difference between this index and these heights, and we multiply them together. So let's take a look at what that means. So here we go. Here's the input and output. So we do need the indexes to know what we're doing to get a clearer picture. So that's the indexes. And so 8 minus 1 right here is going to be 7 on the x-axis. And the difference between the height, the minimum height between the two, times min height, which is going to be 7. 7 times 7, which is equal to 49. And so that's why we have 49. So it looks like it's a sliding window type problem, and what we're going to do is that we're going to get the max area, get every time, and that's going to be this item here, and afterwards we will try to get the next max area by looking closer and closer together until left and right pointers cross. So the window gets shrinks as we continue, and we'll only keep the higher height of the two. If the height is lower, then we'll move it forward. So if this height is here, lower, like we're at 1, then we're going to move to 8. So that means we have a left and right pointer here. So we're going to move the left pointer because this is smaller. And that's how we get this maximum height. We do need to go until the left and right pointer crosses, because there might be a case where we have this extremely high item, let's say 100 here and 100 here. This height might have a difference in x of 1, but the minimum height between the two is 100, giving us a total of 100 height. This is like a skyscraper, essentially, right? And with that, we notice that's why we have to cross the left and right pointer before we're able to complete our algorithm. Some edge cases that we do want to take care of is what is the minimum length of our height array. Let's check that out. The minimum length is 2, and the minimum height is 0. So then edge case wise, this is our edge case. This is a height of 1 and 1, and this will give us an output of 1. Another edge case is going to be 0 and 0. So this is minimum height, and our output should be 0 because we cannot contain any water here. So with that, let's do our time and space complexity and look at what those are. Time is definitely going to be O of n because we're going from left and right pointer, and space, it's going to be just a couple pointers, so it's going to be O of 1. Okay, with that, we're done with our understanding, and we understand the problem pretty well now. So we can quickly get a match, which is sliding window, left and right, and yeah, let's make a plan. So the plan is start left and right. Start right, left at 0 and right at length of heights. While left is less than right, then continue, and to get max area by multiplying the minimum height and difference between right and left. Minimum height of left and right and difference between right and left. We will slide the side that has the lower height closer to the other. And with that, that's our plan, and we're ready to implement. Let's check it out. So first, we do a left and right pointer. So left and right equals 0, and the length of height, as we've done right here. So we're going to get our max area. It's going to set it to 0. And we're going to do a min height and multiply between the two. So while left is less than right, we're going to get the max area equals max of max area between the right minus left times what are we multiplying against? The minimum height between the two. So min of like height left and height right. So with that, I think we're ready to go. Like, yes, that is pretty good. We're gonna take the max of that, and we're gonna return the max area afterwards. So let's check it out, see if it works. I think we have done what we've suggested, and the only thing to do is check whether or not we did it properly. Looks like we went out of range because if left is less than right, we did not finish the plan because the plan was not close enough to us, and we would skim through it too quickly. So left plus equals 1, else right minus equals 1. This right starts at height minus 1. Perfect, and that's the answer to our problem. Yeah, there's nothing else. I think we can run the code for our edge cases and see what happens there. And I think we can start submitting then. Oh, looks like we got a pretty good answer. Not too bad, not too shabby. The code is nice and short. And we can make this easier to read, but we're going to do that after evaluation. And our evaluation is, as we suspected, this is going to be O of n because of the sliding window, loop, crossing, and O of 1 because of pointers, solely pointers, nothing else. And let's make this easier to read. So what is right minus left? So the width and the height. And so we can just take the width times the height. So that separates out the logic, makes it easier to think about. And I think this makes it as readable as possible because we're looking at height is less than right. And that makes it easier to read because we're knowing, oh, which height is lower, then we're going to go choose that one. For some reason, this is not working. Let's check out why. So, is there some bad code somewhere? Int object is not subscriptable. Ah, I see. So this is we changed the what height meant, so we need to rename it so that it's better named. Now we can run the code. Perfect, and let's submit again. And I think this looks pretty good. It's a little bit more readable, and we can also add comments. So the comment is find max area within a container. And let's see, let's paste. And that's it. That's right there. That's our main logic right there, how this works. And we have this right here. And that shows it, what we're doing. Perfect. I think we can change this to min height. And width, that makes a little bit more sense for our wording. And that's even better. And with that, I think we're ready to go. I think this is good code. I think it's very readable, and the next person can read it, and it's very easy on the eyes. So I will, with that, if you have better code that you would like to submit and that you would like to share, please comment. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.